this video we're going to go through past exam question, so the 2011 question 4a Leaving Cert Applied Maths. So in the question we have a block of mass 2√2 kg rests on a rough plane inclined at 45 degrees to the horizontal. It is connected by a light inextensible string which passes over a smooth light fixed pulley to a particle of mass 4 kg which hangs freely under gravity. The coefficient of friction between the block and the plane is 1/4, and we want to find the acceleration of the 4 kg mass. So yesterday we looked at wedges, which are basically blocks, triangular blocks that another particle lays on top of. And we looked at the different forces that were acting on this particle. But what you're more than likely going to get as a question is something like this, where you have a combination of wedges and pulleys, because you have a pulley here at the top. And how you approach these questions is exactly the same as the way you approach pulley questions. You draw your force diagrams first. So let's just see what we think is going to happen here. Well, one of two things could happen. The 4 kg mass could go down and the 2 kg mass could go up, or it could be the other way around. But what you do is you make an assumption. And once you make that assumption, you stick with it. And then if your answer is negative at the end, it just means that things are the other way around, basically. So let's assume that the 4 kg mass goes down with an acceleration a, and the 2√2 kg mass goes up with an acceleration a, because they'll have the same acceleration. Excuse me. So now we always do our force diagrams. So the 4 kg mass one is easy. Force downwards is mass times gravity, 4 times g. Force upwards is t. Our F4 equals ma equation, if we assume it's going to go down, the 4g has to be bigger than the t, so it's 4g minus t equals 4a. That's equation 1, that's probably 5 marks. Next one's a little bit trickier. So I'll go down here so we have a little bit more room. Let's say we have our 2√2 kg mass here. What forces are acting on it? Well, there's definitely a t. It's being pulled up with tension in this way. Gravity is going to be acting on it, and gravity is equal to its mass, which is 2√2 times g. And we're told that it is on a rough surface where the coefficient of friction is 1/4, so we're going to have friction back this way, which equals mu times r. Now remember, we're looking for its acceleration in this direction. And if we're looking for its acceleration in that direction, we need to get all the forces in this plane, in this up-down plane here. So we have t, that's one of them. We have friction, that's another one. But what we have to do is we have to resolve gravity into its vertical and horizontal components. And if you remember from the last video, how we do that is we get our perpendicular component to the plane, and I'm saying to the plane here because the plane is like that. So this first red arrow is perpendicular to it and parallel to the plane. This angle will be 45 degrees, explained in the video yesterday. So this side will be 2√2g multiplied by cos of 45. And that just gives you 2g. This side here will be 2√2g sine of 45, which also gives you 2g. So now when we're looking at our forces, we have another force which is acting backwards on it here, and that's the component of gravity, and that blue arrow is exactly the same as this arrow here, so that's 2g. In order to get friction, we need to know r. Well, r is going to be, this blue arrow will be equal to this arrow, so r is going to be 2g. So friction is mu times r, which is 1/4 times 2g, so 0.5 g. Now when we do our F4 equals ma, we assume that it's moving upwards, so it's going to be the t force. Take away the two forces which are acting against it, which is friction and 2g, and that's equal to its mass, which is 2√2 times the acceleration a. Let's get a little bit more room here. That's going to be t minus f. Friction we figured out is, sorry, that's a minus 0.5 times g minus 2g equals 2√2 times a. That's t minus 2.5g equals 2 root 2 times a. So that's our second equation, and up here that was our first one. So now what we'll do is we'll get those two equations and we'll solve them simultaneously. So we have 4g minus t equals 4a was equation 1. Equation 2 then is minus 2.5g plus t, put the g's under the g's and the t's under the t's, equals 2 root 2a. T's cancel, and we have 1.5g equals 4a plus 2 root 2a. Now we want to get a, so we'll factorize the left hand side, and we get a 4 plus 2 root 2. And then finally we just divide across to figure out what a is. A is going to be equal to 1.5g divided by 4 plus 2 root 2. Type that into your calculator and you get an answer 2.15 meters per second squared. And that's your answer.